All right, so basically, let's look at some of the things that I have written on the board, right? Pay attention, stop writing. Now, we want to know, this is basic lecture on probability. What is probability and what are one or two or three things that you need to know about probability, right? So the definition I wrote on the board is, probability is defined as the likelihood of a favorable event occurring. Okay, so we want to know, in English you can say you want to know how probable an event is to occur, or what is the likelihood of Mr. Precious coming to class today, or what is the likelihood of something to happen or to occur. That is what we are calculating as probability. There are some things that are more likely to happen than others. Okay, so we'll get to that in a bit. So do you understand that part? All right, good. So I now said that this is the general formula for basic probability. Okay, so if I give you this PE means probability of an event. Okay, so probability of an event happening, I just called it M over N. What do I mean by M over N? M represents what is the number of favorable outcomes that we are looking at in that question, all over the total number of possible outcomes. So those are the two things that we are going to be weighing when calculating the probability of an event. For instance, if I say there are 2 girls in this class, right? And there are 5 boys in this class. If I am to randomly pick anybody, what is the probability that I will pick a girl? Okay, so the number of the outcome I'm looking for is the girls, right? We have 2 girls. So out of those 2 girls, we have total number of possible outcome. Total number of people in that class is 7. So the probability of me picking a girl is just 2 over 7. Okay, what's the probability of picking a boy? 5 over 7, because there are 5 boys. Okay, so this is the general formula of probability. We'll be using this a lot. Okay, so in any form of probability, anyhow the question wants to come, basically this is the formula you're going to use. Is that okay? Moving on, I said if PE is probability of an event happening based on this formula, then that means P, insert, if you put this thing means complement, right? Insert, when you put that thing, it means complement, it means not. Okay, so if I say PE, probability of boys, once I put this thing, that means probability of not a boy. Okay, so if this is probability of that thing not happening, okay, so I bought another formula. That means probability of it happening plus probability of it not happening is equal to 1. Okay, so now we have 2 formulas. This one and this one. Is that clear? So if you don't, you're not forgetting this one, don't also forget this one. So if I say, I'll still use that same example I gave. Probability of picking a boy is 2 over 7. That not so? Okay, 5 over 7. Thank you. That's girls is 2 over 7, right? So 5 over 7. Probability of not picking a boy, that means it's a girl I'm going to pick, Abby, is 2 over 7. By the time you add 5 over 7 plus 2 over 7, what do you have? 1. So that is why this formula is also important. Sometimes they might not give you the thing directly. They might just give you the probability of that event not happening. Okay, so you can use this formula to know the probability of that event actually happening. We're going to do examples, right? So don't worry. So where probability of an event happening is a set of fractions between 0 and 1. That's what I mean by this. Okay, so it is in between 0 and 1. You cannot have probability of 2. You cannot have probability of 3. It's not possible. Okay, so it has to be between 0 and 1. If it is 0, probability is usually a fraction. Okay, if it is 0, then that event is not going to happen. Okay, what is the probability of Mr. Precious failing common entrance? Is 0, because there is no, how do I want to fake mass common entrance? If you ask me 3 plus 3, I will answer you 6. So it is definitely sure that I'm going to pass. I'm just giving an example. Okay, so if I say what is the probability of Mr. Precious getting pregnant, it's not possible. So it is what? 0. Is that okay? Because I'm a boy, it's not possible for me to do what? Get pregnant. So if there's an event that it is not possible for that event to happen, right? Then the probability of that event happening is automatically 0, right? So that is the minimum value for probability. The maximum value of probability is 1. So what does, if the probability of an event, if it is 1, what does that mean? It means that that event will definitely happen. Do you understand? What is the probability that it will rain again this year? It's 1, because it must definitely rain again this year. If care is not taking itself today, because the way it has been raining. Do you get? What is the probability that the sun will shine this year? It is definitely 1, because that event must definitely happen. Think of any other event that might happen. What is the probability of just anything, of using the alphabet to write a word? Can you write words with numbers? No, you must use the alphabet. So once an event must happen, automatically the probability is 1. Okay, so that is what 0 and 1 means in probability. Is that clear? All right, so I said even if it is a fraction, right? The higher the fraction, the more likely that event will happen. If you have 2 events, probability of 2 events happening, the first event, probability of that event happening is 1/5, right? And the second event, probability of that second event happening is 3/5. So I now ask you, which of those 2 is more likely to happen? The one of 3/5. So the higher the fraction, the more likely that event will happen. Is that clear? All right, so that's that for this. Let me move on. After we have explained what probability is, right? So when we are doing probability, there are some things you need to understand. These are the 3 things that you need to understand first of all before we start doing examples or classwork. The first one is a random experiment. Now, majority of what we are going to be doing is going to have to do with random experiments. Okay, I said this is an experiment which is repeated many times in an irregular way under similar conditions, the result of which we cannot predict. Okay, so any event, any experiment, and these things can be tossing a fair coin. What is a coin? You know coin now? Maybe 1 naira, 2 naira coin. When you throw it in the air, it either lands on what? Either the head or the tail. Those are the 2 possible outcomes that you can get. You cannot get anything apart from what? Head or good. Now, another experiment is a die. When they say a die, they mean, you know that thing you throw in Ludo? That dice. That's what they mean by a die, one of them. If they say 2 fair dice, that's the 2 of them. If they say a die, just one of them. Okay? They're drawing a card from a pack of cards. Most of their questions required is not what to American card. That one that have queen, ace, king, all those ones. Yes, it's not what they don't used to use what. All right. So those are the kind of experiments we are talking about. So random experiment. What is sample space? What is sample space? So sometimes called event space. This is a set of all possible outcomes of a given experiment. For instance, we're talking about head or tail. We're talking about coins. Okay, what by the time you throw a coin, what are all the possible outcomes you can get? It's either you get a what? Head or tail. That's what I'm talking about. What are all the possible outcomes you can get in each experiment? Do you understand? Simple. That's what I mean by what sample space. What is the sample space for a coin? It's either it's going to be what? Head, or it is going to be what? Tail. Nothing more than that. You can't have any other outcome. So for a coin, it's only 2 possible outcomes you can have. Okay? This is for a coin. We're not talking about combination of coins. Okay? If I have 2 coins, so it's either I'll have head head, head tail, tail head, or tail tail. Is that not so? So that's combination of coins. But if it is a coin, the only 2 things you can have is what? Either head or tassel. Okay? So that is for coin. If it is for a fair die, that Ludo dies, right? Either when you trade, either you have 1, 2, 3, 4, 5, 6. One of them must come. So for a die, you can have 1 out of 6 possible outcome. Is that not so? You can't have more than that. Can you have 7? Can you have 0? So these are one of the things that you must have for a die, right? If it is for 2 fair dies or 3, then we'll now have combinations. Okay? Hopefully, when we are doing examples, we can look at 1 or 2 or 3 combinations. Okay? Then what do they mean by sample point? You know, we have sample space. Sample space is all the possible outcome, right? But the question might be specific. They might not ask you for the sample space. They might ask you for a sample point, meaning that, for instance, I gave an example here. I said sample point if the event is a particular outcome, right? An element of S, then E is called a sample point. What do I mean? Example, the event of getting a head and a tail. So they will specifically tell you the points they want in the space. Okay, they will tell you what is the probability of having a head and tail. Okay, head and tail is either when you throw the 2 coins, right? Either you have one of them head and tail, or tail and head is still the same thing, right? What you know that you have head and you have tail, that's what you are interested in. If you have head and head, no. If you have tail and tail, no. The sample point here is what? Head and tail. So there are different sample points. Okay, they might tell you 2 heads, that is head and head. They might tell you 2 tails, that is tail and tail. They might tell you head and tail, that is head tail or tail head. Is that okay? Is that okay? Are you getting it now? So these are just the 3 things that you can see. Number 1, you will see an experiment in the question, either what's it called, a die, a coin, whatever it is, right? Then you should know the sample space for that experiment. Okay, if you're talking about die, it is different from coin. If you're talking about coin, it is different from card. Okay, so depending on what the experiment is, will determine what is attainable. Okay. All right, so this is it. So experiment, sample space, sample point. No question, right? So let's go to questions, like classwork. So our first example, we have in a city, 3 out of every 60 inhabitants are known to have contracted a new disease. Okay, so this is the information that you have in the question. Out of 60 people, 3 has contracted a disease. Okay, so find the probability that 1 inhabitant of the city selected at random will have contracted that disease. Okay, so let's solve. So for number 1, it's very easy. We are looking for the probability that 1 person. So let's check the probability first. From this, so probability of getting a disease, let me call it P of D. Okay, probability of getting a disease in that city is what? We said it was what? What's the formula? Check your book.
Number of favorable outcome over total.
So number of outcome over number of total events. Okay, all right, so here we have 3 out of what? 60. So total people that total inhabitants is what? 60. Out of these 60, 3 of them got that event you are looking for. Okay, so that is the probability of that event. It's as simple as that. Okay, but the question is asking you, find the probability that one. Okay, so this is for 3 people. Okay, so for 1, we need to take it to what? To the lowest term, right? So that this becomes what? 1 over 20. So your answer is what? Simple. So probability that 1 person selected at random have contracted disease is what? 1 over. Exactly. So that's it. That's for number 1. That's simple as that. Number 2, it says a fair die was thrown 100 times. Okay, so these are the frequency. You know what frequency is, Abby? Yes, how many times something happens. Okay, so if you eat 3 times in a day, frequency of you eating is 3 times. If you eat 10 times, frequency of it 10 times. So frequency is how many times did something happen, okay? So remember I told you that a fair die is what? Dice, right? Dice, good. So dice, the total sample space is what? 1, 2, 3, 4, 5. So I hope you are getting me. Okay, so you cannot have more than these numbers in the die. If you throw the dice, either you have 1 or you have 2 or you have 3. Okay, so the information on this table is telling you that the die was thrown 100, and they throw it 100 times, and then they were counting. How many times did they get 1? They got it 12. How many times did they get 2? They got it 20. That was how they were able to create this table. Do you understand? So this table is giving you the frequency of times this particular number was shown when a fair die was thrown. Do you understand? Okay, so with this table now, we can answer their questions. So these are still basic probability, sha. Okay? All right, so what's the probability of getting a 5, right? So just like I said, the total number, let's call it n total. Total number is what? 100, right? Right? So for this one, 5. Okay? So we can record what is the number of times that 5 came out? 16 times. Good. Okay? They asked us for 6 as well. What is the number of times that 6 came out from the table? Hey, sorry. That 6 came out from the table? 10. So 5 came out 16 times and 6 came out what? 10 times. So you can write that down. Okay? When you've written that down, they're not asking you, what is now the probability that you will get 5? Okay? Remember that probability of getting 5 is the number of times that 5 came out divided by what? The number of total outcome. Is that not so? So number of times that 5 came out is what? 16 divided by what? Total number, which is what? Take it to the lowest term. This is 8 over what? 50. 4 over, let's just use 4. This is 4 over 25, right? To the lowest term. Is that not so? Good. So that's the answer. Probability of getting 5 from this table is what? 4 over. Beautiful. Now let's do the other one. It says, what is the probability of getting 6? Okay? So similarly, this is for option A. For option B, probability of getting 6 is what? P6. Probability of getting 6 is number of times that 6 came out over what? Total number of possible outcome, or total number of times that you throw the dice. Okay? So 6 is what? 10. That also 10 over what? 100, right? Take it to the lowest term. This becomes 1 over 10. So the probability of having 6 is 1 over 10. Now let me ask a very simple question. If the probability of getting 5 is 4 over 25, right? And the probability of getting 6 is 1 over 10, which one is more likely to happen when you throw the dice? Do you think from this information now, can you get 5 or 6? Which one is more likely to come out when you throw the dice? 5, because it has the higher fraction, right? Good. All right. So option C, let's see what it's saying. They say, what is the probability of getting a number greater than 4? What is the probability of getting a number greater than 4, right? Which is very simple, okay? Because the only number from this table greater than 4 is what? 5 and 6, right? Those are the two numbers that are greater than 4. They are asking you indirectly, what is the probability of getting, either you get 5 or you get 6. Okay? So what you will do is, probability of getting 5 and 6, because those are the two numbers that are greater than 4, right? You will now do it, probability of getting 5 plus, number of times 5 came out, plus number of times 6 came out, right? All over what? All over the total number of times, right? So this will give us what? 16 plus 10 over what? 100, which is what? 26 over that should be 13 over what? 15. Are you seeing it? Right? Is that okay? Good. So that's our first example. I'll give classwork, but let's continue with explanations first. All right. Look at this example on the board, guys. Have you written it? Have you written it? Anyway, so two fair dice. Okay, yeah. Two fair dice are tossed together once, right? Find the probability of getting a sum of 7. Now, if you want to get this probability, it's very simple, but you have to draw the table first. Okay? You have to draw the table. The table is going to give you like a clear understanding at first glance of what to do. What kind of table am I talking about? What are the sample points for dice?
1, 2, 3, 4, 5, and 6.
Good. So that is sample point of dice. So we have 2 dice. So I'm going to put 1 dice horizontal and I will put the other dice vertical, right? So like you said, this first dice, let me go write it here. First dice, right? And second dice is here. So second dice, okay? So what are the sample points again? We have 1, 2, 3, 4, 5, and 6. Okay, those are the sample points for the first die. The second die, we can write 1, 2, 3, 4, 5, and 6. Right? All right, so that means that if we have these two combinations, it becomes 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, and 1, 6. So this one will be what? 2, are you seeing the combinations? So with this table, this is a table for two fair dice, right? So let me finish the table. You have something like this. 4,3, 4,4, 4,5, 4,6. Then 5,3, 5,4, 5,5, 5,6, and 6,3, 6,4. Yes, so we have something like this. Okay, so this tells us all the probability of all the events, all the possible events. Is that okay? So with this, let's see. You know something about this table. This table, if you look at the diagonal, you have the same numbers. Are you seeing? Yeah, equal numbers. So let's look at the sample point of the question that we are asked. Okay, they said if the two of them are tossed, find the probability of getting a sum of 7. Okay, so the sample point, let's call it E, right? Sample point E, that is probability of getting a sum of 7. So let us look at all of them that are summed of 7. Okay, so you notice that this is 7, right? This is 7, this is 7. So this diagonal is 7. Right? Is that what you said? Okay. So this diagonal is what? 7. So let's write them. We have 6, 1, 5, 2, 4, 3, 3, 4, 2, 5, and 1, 6. Okay? So that means probability of this our sample points E is what? Total number of this E over the total number of all the points we have here. Right? Is that what the formula? So probability of getting this sample point is 1, 2, 3, 4, 5, 6. It's just 6. Right? Out of everything. Right? So that means what? We have what? 6 out of, yes, 36. So if you count them 1, 2, 3, 4, 5, 6, 6 times 6, that will give you 36. So our answer is 1 over 6. Is that clear? So they can ask you anything. What is the probability of getting the sum of 5? So sum of 5 is this one, right? Which is 1, 2, 3, 4. 4 over 36, that is 1 over 9. They can ask you sum of prime numbers, right? So you know prime numbers are 2. You start checking it out. 2, 3, 5. Okay? So you add all of them that are prime. So it can be any question at all. Okay? But this is a sample question. We're able to, have an idea of how the other questions can be, right? So that means, tell me what we're going to do here. What is the sample point for this equal number? Let's start with that one first. Equal numbers. So what are the equal numbers? The same number, exactly. I've shown you now. 1 and 1. Okay, 2 and 2. 3 and 3. Good. Good. 6 and 6, right? So these are all the words equal number, this line here. So that's how many of them are there? So it's still the same 6 over what? 36. So it's still the same thing. So the probability of getting a sum of 7 and the probability of getting equal numbers are the same. That's what it means. Yeah, right. I'll claim. So mutually exclusive events and independent events, what are they? Okay, so most times, especially if you're writing WAEC or JAM, right, they will most likely not give you the basic probability questions. They will give you questions that has to do with mutually exclusive events or independent events, or sometimes dependent events, which I'll talk about next. Okay, but before that, let me talk about, for those of you that are copying online, if you are going to copy this video online, please, you can pause. So you can pause the video and write, because I need you to write all these notes that I'm writing. Write the notes and then listen to the explanation. That's how to do it. All right, so what are mutually exclusive events? Thankfully, in mathematics, nobody is going to ask you definition, right? But you need to understand, when they say two events or two or more events are mutually exclusive, what do they mean? Right? What do they mean? So two events, A and B, are mutually exclusive if they cannot happen together. Okay? If they cannot what? Happen together. They are usually represented in questions using what? Or. Okay? So when you see or, most times we are talking about mutually exclusive events. What am I talking about? If your mom is pregnant, for instance, right, and she's about to give birth, what's the probability that she's going to give birth to a boy? 1 over 2, right? So it's either boy or girl, right? 1 over 2. Either she give birth to a boy, give birth to a girl, give birth to Esther. Because we don't know what Esther is. We don't know what Esther is. The girl that live like a boy. Look at her. Anyway, I'm joking. Anyway, so if you say what is the probability of her giving birth to a boy or a girl, you are trying to say, I'm joking now. You are trying to say that either she gives birth to a boy, can she give birth to a baby and that baby will not be a boy and that baby will still be a girl? Is it possible? No, I'm serious. You give birth to a baby, that baby is a boy, and at the same time that baby is a girl at the same time.
Like this, but it's red.
How is it red? It's not possible.
I like this though.
I'm talking about female. I'm not talking about she. Those people are not normal. I'm talking about.
I'm not talking trans. Like, no, like what? That. Yes.
What do you mean? Explain.
A girl now can have male development.
I'm not talking about that.
I know, like
That's what they call she-males. They're talking about she-males. No, I'm not talking about she-males. Like they give birth to her now, right? In general hospital. And they ask what is the gender of your baby. You say male and female. It's not possible. That's what we're talking about. That one is they are weird. That's an error, right? That's an error. That's the gene error. Okay, it's just like when you mix two breeds together, you have one weird thing. That is an error. I'm talking about naturally. It's either you give birth to a boy, or are you seeing where that or comes in place? Whenever you have or, that is mutually explicit. Those two things cannot happen at the same time. Okay, you are going to have a lecture now. It's either you have maths or English. Is it possible for maths and English teacher to be here and teaching English and teaching maths at the same time? Yeah? So it's not possible, right? So that's what we call a mutually exclusive event. Okay, so whenever for JAM students, we normally say that's what we call an or event. Or. Okay, so when you see or in the question, you do what? You add. Okay, you add. So they ask you what is the probability of having this or that. You do what? You get the probability of having this, you get the probability of having that, and you do what? You add them together. Okay? So the probability of having a boy is 1/2. Probability of having a girl is 1/2. What is the probability of having a boy or a girl? 1/2 plus 1/2, which is what? 1. So definitely you are going to have either a boy or a girl. Or Esther. Alright. So what is independent events? Independent events. So these are two or more events that they don't depend on each other. Okay. If I say okay, this is the opposite of mutually exclusive. Okay, this one has to do with and, right? It has to do with and. So if I say and, right, they don't depend on each other in the sense, okay, so if I'm going to pick a red pen and at the same time I'm supposed to pick a blue pen, right? It doesn't matter. The probability of picking a blue pen does not depend on how many red pen I pick. It doesn't depend on it. Okay, so probability of picking this one is separate, probability of picking this one is separate, but I want to join them together using and. Okay, so what do I do? Say if you are seeing a question and that question has to do with this and this, okay, probability of this and this, right? You do what? You multiply, right? You multiply this and this. So if you see or mutually exclusive events, you do what? You add, right? If you see independent event that has to do with and, you do what? You multiply. So with these two things like this, when we are solving examples and class work, you can be able to do it. Okay? You'll be able to understand it. Then the last one is okay, I've not written it. Dependent events. Okay, I think that's the last one before we start doing class work and example. That's the end of the class. All right, let's look up. Dependent event. I said two events A and B are dependent if the occurrence of any of them will affect the occurrence of the other. So where you have a question, now see individually, right? These probability questions are easy, but when you are given these questions, there are things that you need to think about. This one now says that we have two events, right? The probability of one happening will affect the other one. Now, I gave an example on the board, right? I said, if we have a bag that contains 2 white balls and 3 blue balls. Blue balls. Wisdom is not here. All right, so we have 2 white balls and 3 blue balls, right? Now, we have a total of what? 5 balls inside the bag. Is that not so? Good. So, if we find the probability of 1 white ball, right, without replacement, especially when you hear without replacement, what does that mean? If you remove 1 ball, you don't replace it, you don't drop it back, you understand? So from having 5 balls, we will now have 4 balls, right? So that means that removing 1 white ball, right, will affect the probability of the next ball. Okay, so if the first probability was over 5, the next one will be what? over 4. So those kind of events are what we call dependent event, because probability of one event will affect the next event. Is that okay? So that's what we're talking about now. Now, time for examples as Esther brought. Look at this question. Look up. Look up. So this is an example. In a class, 40% of the boys, 40% of the boys and 25% of the girls can swim very well. If a boy and a girl are chosen at random, what is the probability that A, both of them can swim very well? So this is a part of mathematics where we also use English. Okay? So when they say both, what do they mean by both? First of all, you need to pick what? The point, the sample point. That's what is going to help you get the what? The probability or the question. Okay? So what do they mean by both? These are the percentage of the boys that can swim. You know what? Let me even write it first. Probability that a boy can swim is what? 40%, which is what? 40 over 100. Lowest term, 2 over 5. Is that not so? Probability that a girl can swim is what? 25 over 100. Lowest term, 1 over 4. So these are the two probabilities that we are working with. Abi? So now let me ask you, if this is the probability that a boy can swim, what is the probability that the boy cannot swim? 1 minus 2 over 5. Remember I said that in the beginning of this class, that probability that something that can happen and that thing cannot happen, two of them will give us what? 1. Okay, so that a boy cannot swim is 1 minus this, which is what? 3 over 5. Is that not so? Probability that a girl cannot swim is what? 1 minus 1 over 4, which is what? 3 over 4. So this is why I'm explaining everything, so that when you see a question, you automatically know, oh, this is this, this is this, this is that. Okay, so with this information now, this question is very simple. Let's start with this A. It says both of them can swim. Okay, so they picked a boy and they picked a girl. So what is the probability that the boy and the girl can swim? Are you seeing it now? So that both means what? And. Okay, which is a what? An independent event, right? And, okay, that this boy can swim and this girl can swim. That is what? Independent. And that is what you use, what? Multiplication. Is that not so? So we get the probability that the boy can swim and multiply it by probability that the what? Girl can swim, which is what? 2 over 5 times 1 over 4. Is that clear? Which is 1 over 10. Right? That's the answer. Are you seeing how simple it is? If you understand it, it is simple. But if you don't understand it, it's complicated. Then for B, they said one of them can swim. So if they pick a boy and they pick a girl, so either the boy can swim. Exactly. Are you seeing? So this one is now what? Or, not and again. Okay? So we are looking for probability that B or G this time around. Okay, so that is what? Probability of the boy plus probability of the girl. Is that not so? So this becomes what? 2 over 5 plus 1 over. Very good. So the LCM is what? 20. This is 8 plus 5, which will give us what? Right? Then the last one, it says neither of them can swim very well. That means the boy cannot swim and the girl cannot. Are you seeing it now? So we can do it. There are two ways of doing this one actually. We can either do it like this. The boy cannot swim. They said and. Okay, so and means times, right? And the girl cannot swim. Is that not so? So we can either do it this way. We can say this one is 3 over 5 times what? 3 over 4. So that will give us what? 9 over 20. Are you seeing? Are you seeing it? Good. We can do it this way. I think this is the one I will use. Yeah. Look up. Let's quickly do this one. Look up. This is the last example before this. So look up. Let's do it. From a box containing 3 white, 4 blue, and 5 red marbles, 3 marbles are drawn. Are you seeing? See the information? We have how many white? 3 white, 4 blue, and 5 red. Okay? So we pick 3 marbles, right? We pick 3 out of them. What are the total marbles we have? 3, 7, and 5, 12. We have total of 12. So out of that 12, we are picking only 3, right? But these 3, one after the other without replacement. Okay, what kind of event is this? Dependent, right? Because if you are not going to replace it, it is going to affect the probability of the next one, right? If you pick 1, it's no longer going to be 12 again, it's not going to be 11. If you pick another one, it will now be what? 10. Okay, but where it gets tricky, this kind of question, is knowing the sample points of what you are looking for. Okay, and then calculating accordingly. All right, so at least 1 is white. Okay, so the sample point for A is, we are looking for probability of at least 1 is white. Okay, that means white, blue, blue, right? White, blue. That's if you pick white, blue, blue, or white, blue, red, or you pick what? White, white, blue. Are you seeing it? Or you pick what? White, white, red, right? Or you pick what? White, white, white. Okay, there must be white in your selection. Are you seeing? Is there any other combination again that we're not seeing? White, blue, blue, white, red, red. Is there white, red, red? Yes. We put white, red, red. Okay. So either this or this or this or this or this or this. Okay. No, we can't have red, red, red because there must be at least white. They said at least one of them must be white. Are you seeing it? So these are the only things that you can have. White, blue, blue, white, blue, red, white, white, blue, white, white, red, white, 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 or white, red, red. Is there another one? Think, please. Is there another combination? I don't think there's any other combination because you have to first of all think of the combination of what you're looking for. So now, the probability that at least 1 is white is us getting either of this. Okay, so either getting this one or this one or this one or this one, this one. You can see, so this is all, but at the same time, probability of getting white, blue, blue is and, right? What do I mean by and? That's you get white and you get blue and you get blue. Okay, so we're going to get each of these probability individually, then use all of them as or. Do you understand? Yeah. Good. So let's do for this white, blue, blue. What is the probability of getting white? Probability, remember, and is what? Multiplication. Why or is what? Addition. Don't forget that. So what is the probability of getting white? 3/12. Is that not so? 3/12. And by the time you remove white without replacement, you now have what? 11. So and is what? And is it plus or times? Times. That's what I want to hear. Times, what is blue? 4/what? 11. Good. Times, what's the last one? Blue. No, we now have 3 blue. If you have removed 1 blue, you now have 3 blue. 3/10. Are you getting it? So somebody should be using calculator to be doing this thing for me fast. So just do, okay, this is 1/4. This will cancel this. Oh yeah, now, as I'm not fast. So this is 3/110. You can check it, Sha. Alright, while she's checking, let's be doing the other one. Probability of getting WBR. Let's check it. WBR is what? What is the probability of getting white? 3/12 times 4/11 times, what is red? 5/10. That's 1/2, right?
That is 1/22.
Yes, that is 1/22. Beautiful. Sorry? The next one, probability of getting WB. That's what? 3/12. Good. times 2 over 11, because when you remove 1, it remains 2. Times blue is what? 4 over 10. Beautiful. That's 2 over 5. So this is 1 over 4, which is 1 over 55. Beautiful. Okay, so let's continue. Remain how many? 3. Okay, I'm coming. Take it easy. The next one is probability of getting W red. Okay, so this is what? 3 over 12 times 2 over times red is what? 5 over, which is 1 over 2, right? So this becomes, this will cancel this, 1 over 44, right? So let's continue. The next one is probability of getting W. Whites is how many? How many whites do we have? 3 whites. So that is 3 over 12 times 2 over 11 times 1 over 10. Is that okay? Good. So this, okay. 200, 1 over what? 220. Beautiful. Then the last one is PWRR. Is that not so? R is red, which is 5. So we have 3 over 12 times 5 over 11 times. Beautiful. This will cancel this. Yes, 1 over 22. All right, so now we have all the individual probabilities, okay? So we want to get, what is the probability of getting this or this or this? And all is what? Addition. So we have to add all the probabilities. So probability is now what? 3 over 110 plus 1 over 22 plus 1 over 55 plus 1 over 44 plus 1 over 220 plus 1 over 22. Is it you that gave me this question? So you must get the answer. Rubbish. So the probability is what? The SCM look like it's 220. Please check if 220 can go, if 44 can go into 220. Okay, she's doing it. Oh, yeah, do it. And tell me. All of them? 9 over 25. Beautiful. So the answer is 9 over 25. And that is what? 55. Oh, okay, sorry. 9 over 55. Okay? And that is for only option A. Okay? Let me tell you. See, if you are writing it online, again, if you are writing it online, please write, I'm about to clean. Or should I just clean up? Or let me do it here. I'll take my camera to that side. I'll take it. All right, let me quickly take my camera to the other side of the board. Yes, so this is the other side of the board. Let's see the other side of the board to answer the other question. So I don't clean the board. So B, yeah, I think it's visible. So B says, let us find the probability that the 3 marbles are the same color. Okay, this one is easy, right? The 3 marbles are the same color. That means we are finding the probability of getting what? White, or blue, or red. So these are the only 3 sample points that we're looking for, right? So let's look at this one. What is white? White is what? No, calm down. White is 3, Abi. So we have 1 over 4, which is 3 over 12. Okay, let me not make it hard. 3 over 12, right? Plus 2 over 11 plus 1/10. It is only like this because we are doing it without replacing the balls, right? Okay. So this is what is the answer? 1/220. Is that it? All right. So let's look at sorry, why are we using plus? It's supposed to be and. And now it's plus, is not for off. Okay. So this is still it. Okay, good. Let's continue. Probability of BBB, right? Blue is what? 4, right? So we start with 4/12 times 3/11 times 2/10. That will give us what?
Guys, I don't know what is small, so it also be 1/9 to finish it now.
What are you saying?
Okay.
Yeah, so this one is 4. So that's where we're going to end for this one. So let's calculate. 1, 5, 1, 3. So 1/55, right? Then the last one is red, right? 5/12 times what? 4/11 times what? 3/10. Please, what is this one? This one cannot cancel. Okay, you can cancel here. 2. Can cancel here. Okay, so that's 1/22. Right? So what is the probability of having this? All. So we have probability is now what? 1/220 plus, because it's now all, right? 1/55 plus 1/22. Is that okay? Please tell me what the answer is so that we can do the last one.
1/22 plus 1/5 plus 1/22
3/44. Good. All right. So this is the probability that they will have the same color. Okay. So the last one says, what is the probability that the 3 marbles are of different colors? So our sample point that we're looking for now is what? Different colors, which is what? We have white, blue, and red. This is it. Different colors. There's no other combination. Is there any other combination? Whether you say white, blue, or red, or blue, it's still the same thing. It's still the same thing. Okay? So we are going to do white is what? 3/12 times blue is what? 4/11. Good. Kabila, you are getting it. Times red is what? 5/10. Beautiful. So this and this is 12. 1/22. So 1/22. That is the probability that you are going to have different colors. Is that clear? Okay. Wait first. Let me look at this last question. I'm saying we did for only one. What if it comes as blue, white, red? Blue, red, white. Are we supposed to do that?
Even if you did, you see the same thing now.
Yeah, okay. Let's check.
It will still be the same thing.
Let's check. Let's check for probability of blue, white, red. Blue is what?
Okay, it's not the same thing.
That's what I'm saying. Without replacement, let's check for blue, white, red. Blue is what? 4/12 times next one 3/11, and the next one 5/10. Let's see. This and this will give us. Okay, so it's still the same thing. It's still 1/22. So it's still the same thing. So whether you do white, blue, red, or blue, white, or anyhow you do it, you are supposed to get 1/22. Please, those of you that are writing online, don't make mistake. Oh, and if you have question, keep the question for me. Okay. So I guess what I'm going to do now is I'm going to give you guys. She said dance and workout. I'm going to give you guys classwork now. Okay. So I'll snap the classwork and I'll put it to this video while I'll send the questions to you guys.